Okay. Okay. Why did my thing just go all fuzzy? Yo. Stop video, start video. There we go. All right. Database access. So last time we built a database in Visual Studio. We used the database tools there. We pulled it up in SSMS. We verified this database exists. You can do that any way you choose. You do not have to use Visual Studio to do it. You don't have to use SSMS to do it. There are a lot of tools to create databases. So all you really have to do is just get one going and load it up with some data. So let's try to start talking to this database. And we're going to do it 3 different ways. So we have this kind of old traditional library called Sql Connection. It's part of system.data, I believe. And that will let you talk to a database. Let me make sure, I think it's this one. We called it CarDB, I believe. That'll let you talk to a database, but it's very, yeah, there we go. You're basically sending strings, SQL strings back and forth to the database, and you're getting a response, and then you can do what you need to do with that. They've improved a lot on that over the years. So we're going to do this 3 different ways. We're going to do it by hand, the way you used to have to do it. You might work on code that's very similar to this older way at some point in your career. I'd say it's pretty likely that you will. Then there's a library that's kind of halfway in between. It gives you some modern conveniences, but it still primarily works off of writing SQL commands called Dapper. So we're going to look at using Dapper. And then at the end, we're going to use Entity Framework, which is it holds your hand the most. You can use Entity Framework without writing any SQL whatsoever. So we'll do it those 3 ways, and we'll kind of talk about the differences or why you would choose one over the other. And of course, if you ask Microsoft's Entity Framework is a Microsoft product. Majority of the tutorials, if you look up a tutorial on how to talk to a database for Microsoft, they're just going to tell you to use EF. And it's really good. It's really mature. It's really powerful. But there is a lot of magic associated with EF. So, you can kind of get yourself in trouble and not be able to fix it if you don't understand the logic of the SQL behind it. And it doesn't matter which project you're working with. One of the questions David had earlier was, do you have to use a model view controller? Do you have to use this in a web page or anything like that? And all of these libraries, the system.data, SQL Connection, Dapper, Entity Framework, they can be used with any project type that you're using in Visual Studio. This could be a Windows form, it could be a console. I'm going to assume that some of those go over to Unity. I don't know what the most popular way to do it in Unity is, but these are built on .NET, so you can use them in any project type that uses .NET. So first, I figured we'd start with kind of a basic console application, and we will use this SQL connection, and we'll kind of see how it used to be, what they used to have to do. And I'm going to do a console app in .NET Framework just to really get in the Wayback Machine here. Let's call this console DB. And we'll just make sure this thing's working. And we're good. We got a functioning console application. So the way we talk to a database or wire up to a database is through something called a connection string. And the connection string typically will contain this server name. And this very first thing that you see in SSMS, that is the server name, localDB/MS SQL localDB. If you are talking to a database on your machine, it's probably either going to be called that, or let's open this window again. If you have an installed SQL Server instance, it'll probably be the name of your computer. This is the name of my computer, desktop PTU 3, whatever. That's the actual location of your server. So I have a couple servers installed on here. I've got localDB, and I've got this actual instance of SQL Server that I have installed. If you're talking to a web database, that server name, it's going to be a URL. So these are a couple of web databases that I've connected to before in SQL Server. The next part of that connection string is going to be your login and password. So if I go ahead and look at this one here, we can see that I have my login and password saved here. That would go in my connection string. Or if you're just talking to a local database, you're just going to use this built-in Windows authentication. So we don't necessarily need a login and a password. Then the next thing that goes in your connection string, so this is the server name. It's going to be the name of the database you're trying to hit. So here's my server name, localDB, MS SQL localDB. But here's the specific database we're trying to get into here, which is this CarDB. Now, getting this whole connection string, you don't have to type this out. I don't ever type this out. What I typically will do is I'll grab that connection string from some sort of application that gives it to me. One of the easy ways to get it is in Visual Studio. We can go to View, SQL Server Object Explorer. Here's all of my different databases on here. And I specifically want to get into this CarDB. So I can right click on that CarDB properties and, sorry, wrong one. I can right click on this local SQL, MS SQL localDB, look at properties, and it'll give me the connection string here. So I'm just going to copy this. There's also, I used to know where this was in here. It's definitely in here somewhere. I just forgot where it is. Is it view connection properties? It gives you the server name. There is a way to get your connection string out of SSMS as well. I just couldn't remember where it is off the top of my head. So as long as we have this connection string, we can talk to a database. We can talk to any database, whether it's local or a web database. So let's go ahead and let's make a method that's going to open up a connection to this database for us. So we'll just start with a static void, and we'll just call this OpenDB. So the first thing I'm going to do, I'm going to go ahead, I'm going to put my connection string in here. You don't specifically have to store this in a variable. I could just put this into the constructor for my SQL connection, but I like to put this in a variable. And we can paste in this whole big ugly thing that I copied here. Now, you do not need all of this. All you really need is the name of the database, that's this data source here, and the initial catalog, which is, sorry, the name of the server, which is this data source here, and the initial catalog, which is the name of the database that you want to open. Integrated security equals true. That tells me that I'm using Windows to log in. This connection timeout is worth leaving here. Will has a pretty good story about a student he tutored for I don't even know how long, forever, before they realized that they needed to increase this connection timeout. And that's what was making her project fail. So I'm going to leave those, but you can get away with just the data source and the initial catalog. Now, what about this right here? Does it actually put a red line on it for me? That's nice. I didn't used to do this. What about this slash right here? Does anyone have any thoughts about this character? Or does this character mean anything to anyone? What if I did that? What if I put an M after it? So this character inside of a string means something. Okay, it's not actually going to put this slash here. This is an escape character. We use this to like make new lines. We use this to indent. So if I literally want to print this slash as part of my string, I can either make two of them. The first one's an escape character. The next one I'm actually adding it to here. Or I can turn this, and I can't remember if this is called string literal. I don't remember the exact name for this. But if you put the @ symbol in front of a string, it causes everything in here to be treated as a string. There are no escape characters in here anymore. So you'll see this. It is fairly common to use these @ symbols, especially when you're creating SQL, because you literally want to send the exact string in there. You don't want to have any characters inside of here that that will interfere. But if you ever have problems with your connection string, this is like the first place to look. Make sure that if you do have a slash, that you're escaping it. So we have this connection string. We're not going to go into where this should be stored today. That's a little bit outside of what we're doing. We're just going to do some quick examples. In general, you don't want your connection string hanging out inside of your C# code. This is not secure. This is not a good idea. Typically, you'll store it somewhere else, but for today, we're going to go ahead. We're just going to leave that there. So in order to do this, we need to install a couple packages here. We need, and packages, just to be clear, packages, you're essentially installing new options for your usings up here at the top. So right now we can use system, console is part of system, random is part of system. We have all of these packages we can use, but I want to use one that lets me interact with SQL. So if I want to install new packages, I go to Tools, and I Nuget Package Manager, and I open something called the Package Manager console. If we go to Nuget, this Nuget.org, this gives you all of the packages that are available for .NET. And we can look at stuff here. And so the one that we're looking for is Sql clients. And I've got one called system.data.sql client. And I can open this up. I can look at it. I can take a look at some documentation for it, how to use it. Well, not much here. Usually there's a little bit more here on the documentation side. And it'll also tell me how to install it. I can install it from the console if I want to do that from here, or I can also use this built-in Nuget Package Manager, manage Nuget packages for solutions. This gives you a UI you can interact with to install packages. So I'm gonna go to the Browse tab. By default, it puts you on installed. We'll go to the Browse tab, and we want Sql client. And the one we're going to use is system.data.sql client. This Microsoft one is the new one. I haven't played with this, so I'm just going to stick with this one because I know it works. This is supposed to replace that other one, and I'm sure it works the same way, but for now I'm just going to use this one right here. So system.data.sql clients, once I have it selected, then it's saying, okay, where do you want to install this? And I want to install this in my project, and then it'll go ahead and it'll check my console DB for me, and I can just click install, and it'll go through this process of installing this package. And then once it's done, we can go over to the installed tab, and now we will see that our project has this library added to it. Okay, so what we can do is we can create a Sql connection object, and we'll say SQL connection. And then when I type this, it's going to say, hey, I don't know what that is. And we should get the option to add a using statement using system.data.sql client. If you don't get this option, then that means that the package is probably not installed. And we'll call this connection. Then we also need a SQL commands object. Now we use our connection string to initialize the connection, to new up the connection. And I just realized I forgot to change this initial catalog. Initial catalog, remember, is the name of the database. So initial catalog is going to be this car DB right here. Yeah. So I'm just going to go ahead and say connection equals new SQL connection. And I'm going to pass in this connection string right here. We also need a SQL reader object. Oh, it's SQL data reader, SQL data reader. So we have all of these objects. We've got our connection. Now we need some sort of query to run here. And this is just going to be a literal SQL statement. And if you're doing this a lot, if you're working in one of these environments where you're writing a lot of SQL, or with one of these ORMs that require you to write a lot of SQL, I highly recommend that you write these in an editor that lets you run them right away. And then paste them in. So I can see this query works. Cool. I'm feeling good. Because in here, you get IntelliSense in here. So, and if you didn't know that you get IntelliSense in here, I will show you how to get it. I don't know why that IntelliSense needs the from statement inside of here to start working. So if I want, for example, let's say I want to select the make and the model, select make and model. I don't have IntelliSense here. And I love IntelliSense. I've got to have it. So what you can do, if you want IntelliSense, as soon as you add your from, and you'll get IntelliSense on the from. I've got from vehicle. As soon as you add your from, if I then go back up to the columns I'm selecting, now I'll have IntelliSense here. Make, comma, model, from vehicle. So if you kind of write your select statements backwards and you do the from first, then you'll get IntelliSense inside of this editor. So I've got this query I want to run. I'm just going to select star. And I'm just going to copy that. And I'm going to put that right into here. We'll say string SQL equals select star from vehicle. So this is the actual query we want to run on our database. Now we try to run it. So first thing we're doing is we're going to open this connection. Now we try to run the command. So I haven't initialized this command variable yet, so I'm going to go ahead and do that first. Command equals, and we can say new SQL command. And then this constructor needs two things. It wants one parameter that is the actual SQL statement that I want to run. Then the second parameter is the SQL connection object that I want to run that on. Okay, so the first one, and you could just type select star from vehicle here if you really wanted to, but first I'm going to give it this string, then I'm going to give it my connection object. Now we use the reader object to actually execute the command. So the reader object executes the command. So we'll say reader equals command dot execute reader. So right here, this command, which has this query in it and this database connection, that's what we're running. Now, this reader object is going to read each line of what we get back. And it reads it with a method called read. And that read method is going to return true or false based on whether or not there's another record still. So what we'll do, we'll make a while loop, while reader dot read. This while loop is going to continue as long as there are still more records to come back from the database. It's going to exit as soon as there are no more records. And so just to test this, what I'm going to do first, I'm just going to console.writeLine. And let's console.writeLine this reader object and just see what we get. So then when we exit this while loop, we know that there are no more records in the table. We got them all. And so what we do here is we close the connection. And then down here we have a catch. And this will catch, we'll hit this catch if anything goes wrong with our SQL here. And so I'm just going to catch a generic exception. And so if anything goes wrong, we'll get our message. Okay, so any questions about this before we try and run it, see if it works? just to be clear, this is not how you will see this done anymore. Sometime, if you go back and look at an older code base, you will see some of this, but most modern applications today are built with some sort of ORM. We're going to get into one of those in a second. Okay, so let's go ahead and run this. So we should get hello. Then we called our OpenDB method, and I'm not quite sure. We're going to see here. We're going to see something. We're going to see a couple things printed to the console. Although if our connection doesn't work, we're going to hit this error message down here. Cool. So we got hello, and then we got two console.write lines out of this reader.read. And the reason we got two console.write lines out of it is because there were two cars in that vehicle table. So we have to do something a little, we got to be a little better here with this reader object. So this reader gets back a response, and it doesn't really know what's going to come back. There's no, like, it's not going to sit here and it's not going to be like, oh, okay, ID's an int, model's a string. It doesn't, what comes back from this is objects. So what we can do, and just to be clear, let me, where's my draw? What this reader is going to give us back, it's going to give us back an array. That is white, that's unhelpful. This reader is going to give us back an array that has all of the information in each of these rows. So at index 1 of the array is going to be the ID. Sorry, index 0 in the array, it's going to be the ID. At index 1, it's going to be Ford. And so on and so forth. At index 2, we're going to have the make. At index 3, we're going to have the VIN. And at index 4, we're going to have the year. And so that's what this gives you back. It gives you an array with all of this information. And that array, it's an array of objects. I mean, we've talked about arrays. When you make an array, you make it like an array of ints. Well, this has got an int here. It's got a string here, string here, string here, and an int at the end. This is an array of objects. So we have to handle on our own any of the casting that needs to happen. So first, let's go ahead and we'll say reader. And we have a method here called getValue. And essentially, this takes the index. And we decided, well, at index 0, that's going to be the ID. And I'm going to format this string because we'll go ahead and we'll say ID. And then we can make this reader.getValue a variable inside of a string. You can also concatenate this, same thing. I just don't like concatenation personally. Make, what was the order here? And I have to remember this order too, because the model comes next. Model's at index 1, makes at index 2. So we'll say model, and then reader.getValue 1. And we'll say make. Oops. And that'll be enough. I won't get the other two. But now we should actually see the car's information. So for each row, I'm going to print out the ID, and then I'm going to get whatever values at the ID. And if I mouse over this getValue method, notice I'm getting an object. I'm not getting an int. I'm getting an object. I'm not getting a string. So let's run this. And I've got ID 1, model, Ford, make, Mustang, so on and so forth. Now, this reader.getValue as an object, this is not particularly useful to me as a programmer. It's an object, like what am I going to do with an object? I can't, let's say I wanted to increase the year by 1 or do some sort of calculation with the year. I can't do math with an object that doesn't know what it is. So what we ended up having to do is we'd have to sit here and we'd have to manually cast all this stuff. I'd say int id equals, and then int.parse or convert.to, either works, reader.getValue at 0. Oh yeah, I'd have to use convert. I should have gone with the suggestion. That's right. And there's no IntelliSense here. Like, I'm literally having to remember what all of these are. It's not going to bail me out if I try to convert to the wrong data type here. There is no, I'm not going to get any red lines. So that's real disadvantage. So what they would typically do with all this stuff is we would create a C# object out of them, one that's easy for us to work with, and we'd get all this information out of it and we'd create an object. So we could make a vehicle object that has an int ID, it has a string model, string make, int year, and then I could use each row of this to make a vehicle object. And then I could use that vehicle object like any other object in my code. So we'll go ahead and we'll make one of these. These are typically called models. They call these models. You might also hear them called entity models. And what that term entity model means is, all it is a C# representation of a table in a database. And it just makes it easier for you, the developer, so you're not having to always deal with something like this if you want to do a calculation. You instead, you take all these values and you use them to make an instance of a model. So I'm going to add a model class here. I'm going to right-click Add Class. And we'll call this vehicle. And all this is you'll also hear these called POCO, or if you're in Java, they call them POJO objects. And these aren't really something you're ever going to do inheritance with. They're very, very simple. It's just a basic store of data for these 5 variables right here. So the way you typically make them is through something called properties. You usually don't mess with a constructor for them unless you have to. And I make these properties so that they match up exactly with how this table is. And so what I'm going to do, I'm going to pull these up side by side. I've got SQL Server Object Explorer here. Here's my vehicle table. I can look at the designer. And now I can see exactly what's in that table. And I'm just going to split these out because I have the memory of a goldfish here. So now on one side, I've got the design of my database. Over here's my model class that I'm making. And so I need a property for the ID. And I'm going to give it a get and a set. Now I need one for the model. Models of varchar, but we don't use varchar in C#. We use string. Now we have another one, make, vin, year. There's a shortcut for these. Since we're making properties, we can make them with prop tab, P-R-O-P, tab. When you generate them this way, it's automatically going to highlight the data type. So then you just have to change the data type Then you hit tab again. It moves you to the name. Now we can just change the name to make. And now I can hit Control-Shift-Enter to make a new line. And you can make these very, very quickly. So we got another one. We got a varchar on bin. So we'll say prop tab, string tab, bin, Control-Shift-Enter, prop tab, int tab, year, and then we're done. So all this is just a C# object that's representing what's in this table. It doesn't have to do anything complicated for us. It's just going to store this information in a way that we're used to working with in C#. So I'm going to go ahead and close this design over here. I don't need that anymore. So now, instead of me doing all of this printing and all of that, I could make a list of vehicles. And I could add everything in the database to that list of vehicles. And then I could do whatever I want to with that list, just like any other C# application. So what I'm going to do, I'm going to go ahead, we're going to make a list of vehicle as part of this program here. And we are in a console app, so make sure it's static. And now, instead of just sitting here and printing out get value or anything like that, I'm going to go ahead and I'm going to add a new vehicle to this list with the correct data types for every record in the database. So I can say string, and I already forgot the order again. Okay, model. It's model, make, VIN, year. So string model equals and reader dot get value. Now you can try to cast these automatically. You can use get string here. But just to be clear, this is no safer than what I'm doing up here. If the wrong data type comes through, we're going to be in the same kind of situation. String, I think make was next. I already forgot. String make model. What did I decide? VIN. Now we're getting at index 3, and int year equals reader, and there's probably again int 32 at 4. And this works, but it's not real safe. I'm getting at these indexes. I'm getting at these indices. If I, for example, go back and change this table and add another column, I'm going to have to go and make significant changes to my code in here. Kind of a pain in the butt. So we can use all of this stuff that we just got from the reader, and we can use that to make a new vehicle. And we can just set all of those properties. Vehicle.year equals year. Vehicle.model equals model. Make equals make. Oops. But notice I'm having to do all of this by hand. I'm having to get these responses that we're not totally sure what data type they are. Then I'm having to put them inside each of the properties. And vehicle.id equals ID. And what am I missing here? Vehicle.VIN equals VIN. And then we can add this to the list. So now we've gotten a response from our database, and then we've taken that response and we've turned it into C# objects that we can work with on our application here. And so now if I want, for example, want to display all of these vehicles in the list, I could now make a method that takes a list of vehicle and it displays the vehicles. We'll say static void display vehicles, or I could do whatever I wanted to do with them. Anything that I could do on a C# object, I can now do on these vehicle objects. And we'll just loop through for each vehicle in the vehicle list. And we'll just do those two just for time's sake here. Now I can call this display vehicles method. And let's see if it works. Vehicles.add vehicle. Vehicle equals new vehicle. Vehicles equals new vehicle. Does anyone see it? Oh, I see it. We made this list of vehicles and we never newed this list of vehicles up. All right, let's try again. Okay, and so now we have this list of C# objects that we can use. We can use this anywhere in our application. But this wasn't super efficient. This is kind of a pain. And just to be clear, this whole method only runs one query. So we'd have all these different kind of strings of SQL running around. But this is the old way of doing things. And a lot of, Android was still doing this for quite a while. They now have a new library called The Room. But this was how you did things in Android. You got I forget what the reader object was called, but it was very similar. It was called something else though, and you literally got these values that you had to then go cast by hand to turn them into whatever object you needed. So, any questions about that before we look at a slightly better way? All right, so let's go ahead and let's look at a tool called Dapper. So what these tools are what's referred to as ORMs, and that stands for Object Relational Mapper. And they call them that. Essentially what we've done here, where we had to get this response, we weren't sure what the data types were, and then we had to, this is essentially trying to this is doing the cast for us. We had to cast from object to string and object to ID, and then we could take all of that and make a vehicle out of that. ORMs will do that for you. And there's a lot of them. The two most popular ones for C# are Entity Framework and Dapper. But whatever language you're in, Java, Python, they have ORMs out there. Now, Dapper is really lightweight. It is closer to this right here than it is to Entity Framework. It still has you write queries in SQL. It does a little better with the variables, but it makes you write queries in SQL, but you don't have to do all of this casting here. So let's do another example. And this time, just to show you can use this, we could have used Dapper in this console app. Just to show you can use this with anything you want, we'll go ahead, we'll make a Windows format for this one. And we'll call this WinForm Data Access. Now, instead of doing framework, We're going to do the latest and greatest here, .NET 6. No matter what version of the library or what your front end UI is, these are going to be fairly similar. All right, so we've still got this program.cs. We got form1.cs. And we want to talk to a database. So I still have to install packages. This time I'm going to install the SQL client, the same one I used before. Dapper still uses this, but I'm also going to install a package called Dapper. So tools, Nuget package manager, manage Nuget packages, click on the browse tab. We're going to get system.data.sql client to install that. And then we're going to install Dapper. And just check the project and it'll install it. Now, what Dapper does, Dapper provides a set of extension methods for the SQL client objects. So what we can do, we're still going to create a SQL connection here, but now on that SQL connection, I can say .query. And it saves us a lot of time. And where it really gets cool, I can take that query method and pass it a generic and tell it what I want back. So in this example, we could say, hey, run this query on my connection and give me a vehicle back. And then we don't have to deal with all of this casting that we had going on. So let's go ahead. This time, instead of just putting all my code in form 1, I'm going to go ahead. I'm going to make a class that's actually going to be our data access class. So just right click on this project and we'll say add class and we'll just call this data access. And a lot of things are going to be the same. We're still going to have this connection string. Do I still have it pasted? No. So let's go ahead and make our connection string. And we'll just grab this right out of here. Initial catalog is car DB. And I'm going to take everything after the connection timeout, just don't need it. And then make sure you have an escape character here so that the slash actually makes it into the string. And I'll go ahead, I'll make my SQL connection here. And when we make this, we're going to get a red line and we need a using statement for system.data.sql client. Go ahead, we'll add a constructor. Constructor is going to initialize our connection, and it's going to initialize that connection using our connection string. So far, this isn't that different. than what we did previously. So now what I can do, I can create methods inside of this data access class. So this data access object is going to be an object that I can put anywhere I want, and then it'll provide me with methods I can call that will give me back vehicles or give me back, what were the other? I think we had vehicles, loans, and something else in our database. It'll give me back those C# objects that I need. So let's make a method that returns all of the vehicles. So we'll say public list of vehicle. You're going to see people using IEnumerable more than list when they do this. But just for now, if you know what interfaces are and you're comfortable with them, IEnumerable is the interface that list implements. If you are not comfortable with interfaces, really understand them yet, you can think of IEnumerable as a list. It's very, very similar. And I've got this red line here because we don't have a vehicle class. So let's go ahead and let's create that vehicle class. So we had an int for ID, prop tab tab, int ID, Control Shift Enter. We had a string. Thank you, OneDrive. We have a string for make. We have a string for model. Stop it. Don't show this reminder again. And then we have a string for VIN. And then it was an int for year. So now I have this vehicle class. It's ready to represent any given vehicle in the database. We can go back to our data access, and we've got this method called getAllVehicles, and it's going to pull all the vehicles out of our database. Okay, so the actual SQL command we want to run here is select star from vehicle. Again, I would write this in SQL Server Management Studio first and run it to make sure it works. However, I'm feeling pretty confident about this one. I think we got it. So now we open the connection. So we'll say connection.open. And now, instead of kind of the complicated process we had before, we can use one of these methods: query, query first, query single. And what these will give you back, if I give this query single or query, if I give this a generic, oh, I'm sorry, we're doing all vehicles. Whoops, multiple rows, wrong window here. All right, we've got query, we have query async. And so what this is going to give me, if I give this query method a data type right here, this is a generic, just like when you make a list of int or a list of vehicle or a list of student, this query takes a generic and it's going to give me back an object, or it's going to try to give me back an object of whatever I pass here. So what we're going to get back, we're going to get a list of vehicles. So a list of vehicle, we'll go ahead and call this vehicles. Equals connection.query. And if you can see as I'm typing, I'm not getting any IntelliSense here. And that's because we haven't added Dapper, and Dapper adds extension methods onto here. So I'm going to add my using statement. We'll say using Dapper. Okay, now that I've done that and I say connection, I can say dot query. I give this a data type. Okay, this is what you're going to give me back. You're going to give me back a list of vehicles. It's an IEnumerable of vehicles, but it's close. And then we give it the query that we want to run. So connections, that one doesn't have the generic, just like here, connection.query. This, they're asking for a list of customers, and this is the actual string that they want to run. And we're doing the same thing here. This is what I want you to run. Now, I have a red line here. And if you ever see this, this is, oh, not connection, right here. And what this is saying, it's saying can't implicitly convert from an IEnumerable to a list. Now, if you understand what that error means, you can go ahead and fix it. If you don't, just keep in mind IEnumerable is very similar to a list. You can almost treat it like one. And if you ever need a list from an IEnumerable, you can just call toList on the end of it, and you'll get one. Okay, we've got all of our vehicles. Now we close the connection. And then we can return vehicles. And now we have a method that we can use anywhere in our program that's going to go into the database, hopefully, and get us all the vehicles. And it's going to give them to us as a list of vehicle. And we know how to work with that in C#. This is something we're familiar with. So just to verify this is working here, I'm just going to go into Form 1, View Code, and we'll go ahead and we'll just new up one of our data access objects here. DA equals new data access. Yeah, I did that wrong. I don't want to take this in here. Whoops. Don't take anything into your data access constructor if you're doing this along with me. We could also take in a connection string inside of this data access constructor and then new it up that way. And so let's go ahead and let's just hard code a list here. And then I'll just try to pop up a message box just to see if we got anything back. And then once we verify it's working, we'll kind of put this where we want it to go. So we're going to run data access.getAllVehicles. That's going to give us a list of vehicle, hopefully. And we'll just pop up the first vehicle, some information on the first vehicle. And let's call this vehicles so it's clear what it is. So we'll go ahead, we'll run this, and hopefully we should see for Mustang. Mustang should pop up in a message box for us. And we got it. Very cool. So I'm going to go ahead, I'm going to make that list of vehicle. We're going to go ahead and make that a field. And we'll go ahead and just leave that in there for now. So we've newed up the data access object, but we're not going to populate the list of vehicles. Maybe we'll make a button that does that. So let's add some more stuff. We can get all vehicles, but what if I want a method that gives me one vehicle that matches a given ID? So I can write that. So we got public vehicle, and we'll just call this vehicle by ID. And we're going to take in an ID as a parameter here. So we have a few different options. We use this query single when we're only expecting to get back one row. And if we're searching by ID, ID is a unique identifier. So we should only get back one. The ones I like to use, so what the difference between this query singular default, one of them throws an exception when something goes wrong. The other one returns null. So if I give it an ID and that ID doesn't exist in the database, this one's going to give me an exception, which means I need to wrap it in the try catch. However, this one gives you null, and it's really convenient because you can just run an if statement to check to see if it's null or not. So I typically prefer to use this one, but you could use either of these. So again, we need our SQL statement, and if you want, we can write this right over here. Select star from vehicle where ID equals 1. Okay, cool, that works. So I'm just going to copy everything but the 1 here. We can say string SQL equals, oops. And now on to the end of this, I'm just going to concatenate whatever gets passed into this method, ID, and I think it does the toString for us. It does. Okay, so this is the query we're going to run. We're going to pass some sort of number to this method, and we're going to run this on the database. So we can say connection.open, and then we're going to get back one vehicle equals connection dot query, and I'm going to use query single. You use query single or query singular default. Either way works. And what I'm asking for from this is a vehicle, and then I'm going to pass it my SQL statement. So this is going to give us one vehicle back. Connection.close, and then we can return the vehicle. So let's see if this one works. Let's go ahead and let's get a vehicle. Vehicle v equals da dot vehicle by ID. Let's see if we can get the vehicle with an ID of 2. And then again, I'm just going to pop up a quick message box. And if we get the ID of 2, we should be getting Camaro here. And we got it. Now this data access class, there are a lot of different ways you can package these. You will see people that make a separate data access class for each of their entities. Maybe they have one data access class that only returns vehicles. They make another one that only returns loans or whatever their other objects are. Other times you're going to see where everything's built into one. So let's go ahead and let's interact with this a little bit from the UI. I shouldn't need that. Not sure why that's popping up there. There we go. Toolbox. Toolbox, hello. I'm gonna close or reopen the project. I'm not sure why Toolbox is not opening. Windows Forms on .NET Core is a little strange sometimes. They didn't have it for a long time. They added it within the last few years, and it doesn't always do what you're expecting. And also the designer takes a long time to load for some reason. It's almost like Windows Forms is obsolete and needs to go away. Oh, that's my sample project. WinForms database access. Toolbox. Huh. I've seen this before. It builds, it runs. Come on. Well, I guess we'll just use my sample project that I built earlier because that one is working. With custom components, I just want the regular components. So the application is still running, terminate all. All right, we'll try this one more time, and if it doesn't work, then I'll just use the sample one. Will, have you ever seen this before?
Yeah, actually, I was more surprised. I would have been more surprised if I saw you get tools on the .NET Core version. This tends to be what I experience. I'm booting up Visual Studio now and seeing what.
Oh, I have another version on .NET Core. It's
I don't know. Yeah, let me see what I can pull off. But this tends to be my experience. Which is kind of just mocking you because it's like, here's a win form, and it's literally just
I know.
the form. Oh, you're right. I got my toolbars hacked on this .NET Core version. I'm not sure what's going on.
Let's see if I can restart. Well, okay. This is the exact same version of .NET here. I don't know why this one works and that one does not. Now is this one not going to work? No, this one doesn't work. I mean, clearly it worked at one point. Well, that's fun. Okay, so Windows Forms is kind of an outdated UI. We use it because it's really quick and it's easy to kind of spin something up. But in general, you're usually going to be using this to interact with some other kind of UI. But all the database access is the same. You can still just use Dapper. You can still just use Sql Connection. This load vehicles button, all it does is just runs that select star from vehicles. And then we can actually change any of these. I can click on one of these and we can go down here. If I wanted to change the year on this Camaro, I could. And that's that pop-up's telling me how many rows were updated. And then we load the vehicles again and we can see that it's changed in the database. So what's different here on this one? There is one more method inside of our database access. And what's going on here, we can see we've got this update car method. And why this is so cool, now instead of me having to like go through and write all the SQL, I have this database access class that all it does, it just takes in a vehicle and then all the SQL's in here. So here's the actual SQL statement that gets run on the database. It's update vehicle set. And in this example, my UI can only change the make, model, and year. So I only change the make, model, and year. So we're going to set the make equal to, and for those of you that are comfortable in SQL, you might remember that the way you create variables in SQL is with this @ symbol. If you want something to be a variable, when you're doing stored procedures, use this @ symbol. So we're going to set the make column equal to a make variable. We're going to set the model column equal to a model variable, year equal to a year variable. And we're going to do that wherever the ID is equal to an ID variable. And then when we run this command, we use the execute method. We pass our SQL string, but then we also pass an object here that sets that ID variable to the ID of the vehicle, sets the make to the ID of the make, model to the ID of the model, year, so on and so forth. And so the way this execute method works, if we go back to the Dapper documentation, so the way execute works is it takes in Oh, they don't have a real good example where they use variables, but it takes in your SQL statement and then it returns you how many rows got changed. So in this case, since we're updating based on the primary key, it's only ever going to change one row. This is a unique identifier or none if that primary key doesn't exist. And so that's what's coming back here. We're getting the rows changed back. And so this method, I just have this method returning an int, which is the number of rows that got changed. But in my code, I can just call this method and pass it a vehicle. So if we take a look here at my update button, all it does, it just changes the make, model, and year of whatever vehicle is selected in the list, changes those properties based on the inputs, and then it calls the update car method and takes in a vehicle. So this Dapper is a really good choice. It's very popular. If you decide to use this for one of your projects, you're going to find a ton of documentation on it. And it's kind of halfway in between what we did previously and Entity Framework. And Entity Framework really holds your hand. I mean, you don't have to write any SQL in EF. So it's a little bit in between. It maps the return to objects for you. But it still kind of gives you this power of writing your own queries, which some people really like, and some people do not like so much. Let's go ahead. Toolbox. I just have to restart my computer, but let's go ahead and let's see what this would look like if we did this in Entity Framework. So what Entity Framework will do for you, Entity Framework actually will create your models for you. It builds this data access class, this class we wrote right here using Dapper. It builds this class for you and it calls it a context. It calls it a DB context. And there's two ways to work inside of Entity Framework. You can either, in this case, we built the database already. So you can use database first. And so you'll point Entity Framework at a database, and then it will generate all of these model classes, and it'll generate this context class. The other way you can do it is you build these model classes first, and then it does the opposite operation where it actually makes you a database out of your model classes. So let's go ahead and let's see what that would look like. We have the database already, so we're going to be using database first. And let's see, with this vehicle, Entity Framework's going to make a vehicle class for us. So I'm just going to refactor this, and we'll call this vehicle, and we'll call this vehicle Dapper, just to be clear. Okay, Entity Framework. Okay, so this is the most popular one. If you're looking at Microsoft documentation, they're pretty much always going to tell you to use EF. Oh, there's like a little. This is cool. I wonder if you can do this without the command line now. So there's two basic ways to do it if you're looking into using EF. Code first, so EF code first is where you make the models first, or database first, that's where you build your database first. If you are starting a brand new project from scratch with no database, code first is really popular. In general, I like code first a little bit better. It sets up something called migrations, which are really cool, meaning that if your database or your models change, you can have like a version history where it'll go through all the changes you've ever made, and it's really easy to make changes. But database first works as well. If you're working on an existing database, you're working with a legacy database, we can just point Entity Framework at it, and it'll go ahead and generate for us. So that's not what I want. I want the one with scaffold DB context. There we go. So it does make you use a little bit of command line to use EF. It's not a lot, but it can be a little bit scary at first if you're not used to using command line. So there's 2 packages we need to install here. Actually, I think there's 3 to use Entity Framework. Tools, Nuget Package Manager, manage Nuget packages. And the first one I want is Entity Framework Core. I have this one right here, Entity Framework Core. So we'll install this. Then Entity Framework Core dot SQL Server. And you can use EF with any database you choose. You are not locked into SQL Server. You can use MySQL. You can use SQLite. And then Entity Framework Core dot Tools. This tools package is what actually lets us use the command line. And we're going to use the command line to generate our models in our data access class. Now, I actually made this into a Word document because I always would forget the syntax of this because it's a little strange. But this command that we're going to run, it's called scaffold DB context. And what it needs a connection string. So if we say scaffold DB context, then we put the connection string here. Then we tell it what kind of database it is. And in this case, we're using a SQL Server database. Next thing, we tell it where we want it to put our models. And remember, model is a C# class that is a representation of a row in a database or an entry in a database. The name of our DB context goes next, and then the directory where we want that to go. This force command, you don't need this the first time, but it's really good to use in the future. What this force command will do, it'll overwrite anything that's previously been generated. So let's say that I go back to my database and I add another column in the vehicle table, maybe all-wheel drive bool, yes or no, something like that. I can then go back and run this command, and it'll overwrite whatever I have previously, and it'll update my models for me. So this is kind of the template. This is what we actually need right here. So in this case, we were targeting a database called Dog Walker. So I'm probably just going to copy paste this, and I'm just going to change the information. So the initial catalog we're targeting is CarDB. And then our output directory for our models, I'm going to leave that as models. That makes sense to me. We'll call this class CarDB context. We'll put that in data, and then we're going to force it. And then we can copy this whole command over here. There are a lot of templates for this. If you're doing this and you want this template, I'd be happy to give it to you. It is really easy to make a typo here. And if you're running Entity Framework commands in the command line and they don't work the first time, do not get frustrated. There's just, this is quite a long command here, and any typo can mess you up. Okay, so we're going to run scaffold DB context. Here we're pointing it at our database. This whole thing right here is our connection string. We're telling it I'm using SQL Server, put my models in a model directory, put my context in a data directory. And if we get it on the first try, that'd be cool, but it doesn't always happen. And we got it on the first try. And just to be clear, I should have stopped there for a second. The way you open this console is you go Tools, Nuget Package Manager, and you open Package Manager console, and that gives you this right here. So let's see what we got. So we can see we've got a data folder, and it's got a class in here called car DB context. This is the equivalent of this data access class that we were making ourselves, but here Entity Framework gave it to us, just handed it to us. We didn't have to make it ourselves. We also have a models class, and this models class has all of the tables in our database. And you'll notice it's got a few extra things here. I'm not going to go in depth as to what all of these things are on top. Just focus on the properties. You know, it's got same thing. Here's our vehicle class. It's got an ID, model, make, VIN, year. Just pay attention to those. If we want to go more in depth into the Entity Framework, we could do that another time. But you know, same thing that we made: ID, model, make, VIN, year. We got the same thing for sale and loan. Again, these are just representations of our sale table, and this is just a representation of our loan table. Now, if we look at our car DB context, this class has the connection string. It automatically pulled the connection string in for us. Again, this connection string is in C# code. That's not optimal. That's what this whole warning is here. But it'll work for now. And we also have these on model creating methods here. And what this is doing, this is actually creating these relationships. Okay, so here's all of the relationships that we have defined in our table, but they're laid out in C# code. So the main place where you want to go look here are these three collections: loans, sales, and vehicles. DB set is another class like list that also implements IEnumerable. And you can kind of think of it as a list. You can do a lot of the things with a DB set that you can with a list. So if you looked at this right here and you read this as, oh, this is a list of loan or a list of vehicle, you'd mostly be right. So inside of this car DB context, we have access to something called vehicles. So let's go ahead and let's try and use this, and let's see how different that is from using our Dapper application that we had previously. Okay, so before we were doing things, we were calling methods like get all vehicles. Okay, this is our Dapper object. But now with Entity Framework, what I can do, so we named this car DB context, and we'll just call this context. And we need a using statement. And we'll go ahead and we'll new this up in the constructor. If we go more in depth into this some other time, I can show you how to not have to new these up. But for now, we'll just new them up in the constructor. So now with this car DB context, I can access any of these DB sets. And these DB sets essentially are a list of all the vehicles. So let's go ahead. Let's try to hit one of them here. Let's just make a button that will pop up. We'll pop up the first vehicle in the database. Oh, I can't make a button because my toolbox. This toolbox is pointed at the wrong thing. I'll just do it in the form one load. That's really irritating. Okay, so we could get a vehicle out of the DB context. So I'll say vehicle. And we need a using statement here for our models folder. And we'll use the context. Now, if I want to get to the vehicles, all of the vehicles inside of my DB context, say context.vehicles. And then on here, I can run, kind of similar to what we were doing on Dapper, I can run some different methods here. And one of them is singular default. This is very similar to what we did in Dapper. It's either going to give me one vehicle or it's going to give me null if it doesn't find anything. And so what we have to do in here, we have to give it some sort of criteria to find that vehicle on. And if you're not familiar with the syntax, it's a little bit strange at first. But what I'm saying is I want the vehicle whose ID matches 1. Okay, and that's what this is going to give us. And we'll go ahead, we'll pop up a message box here with just some information about that vehicle. And just to be clear, okay, and we were able to pull it out. So here, when I'm inside of Entity Framework, I'm not writing any SQL. Okay, all I'm doing here, I'm using built-in C# methods. The singular default is part of the link library. It lets you query collections. You could use this on a list. You could use this on an array. At least I think you can use it on an array. And I'm not having to write select star. So instead of writing select star from vehicles where ID equals 1, I write something like this. We could get all of the vehicles. We could make a list of vehicle. And we'll call this vehicles 2, since I already have a list up there of the other one, equals context.vehicles, and we could get them all. Okay, and what this is essentially doing right here, this is doing select star from vehicles for me, but I didn't have to do that. I don't have to write any SQL here. And that's kind of the, that's its greatest strength and its greatest problem, is that you can get yourself, you're still living, everything you're doing is still translating to SQL. So you're still subject to all the same rules that you would be in a relational database, but you're not writing any SQL. So sometimes you can get yourself in a little bit of trouble trying to do stuff that doesn't line up with how things work in a database. If you want to change, one of the really cool things about EF So when we wrote this, I guess we didn't write it because I switched projects, but this data access method that we wrote here, this was, I wouldn't say it was real complicated, but it was kind of a lot of typing. It was a little bit of a pain. We had to create this anonymous object here. If I want to change an object using EF, I can just change it, and it's really easy. So here I got my vehicle out of the database, and I could just say v dot, we'll say v dot, we displayed the make down there. Let's change the make. And now it's going to be a Honda. And when I make changes like this, Entity Framework actually tracks the changes. Entity Framework says, okay, this vehicle was retrieved from a database, and that has now been changed. And we can just say context dot save changes, and that'll actually update our database. I don't have to. In some other ORMs, you'd have to pull the object out, change the property, run an update statement. This will do it all for us. Now let's go look at our, oh, did I change? What did I change? We can go run our select statement here and we can take a look and we'll see that we did, in fact, update the database. So we have a Ford Honda in the database, nice. But it's really convenient. I didn't have to write any SQL. I pulled something out, I changed the information about it, and we can put it back if we want. Run it again. Now we're going to update the database. Now we're going to have a Mustang. So sorry about the toolbox crashing in the middle. That kind of threw us off a little bit here. But when you're wanting to access databases, you've got a lot of options, and they all work with all project types. If you want a lot of control over the exact SQL that you're running, I would use Dapper. If you like this kind of magic that's going on where you don't have to use any SQL and everything just kind of works, Entity Framework's a good choice. It does give you a whole lot of code here that, since you didn't write it, you might not understand, and that's definitely a downside. If there's a bunch of code you don't understand in your program, it can be really tricky to fix it if something goes wrong. But EF is mature, it's fast. One of the cool things that EF does for you also that you don't get with Dapper, EF will run concurrency checks for you, which is really handy. And what a concurrency check, meaning that if two people try and modify a record at the same time, EF keeps track of that for you. And it'll throw something called a concurrency exception. It'll say, hey, if, for example, if we're running this and we have two people accessing this database, and Kristen tries to change the model name to Ford, and I try to change it to something else, it's going to sit there and it's going to say, hey, this record has changed since last time you retrieved it, and you have to keep track of that for you. Whereas in Dapper, you have to do that yourself. We have to add a column keeping track of what version the data is, and then you check against that column before you let someone modify it. So it does a lot of stuff for you. It's really powerful, but sometimes it kind of holds your hand a little bit too much. Any questions about any of that? I saw you unmuted, Kristen, but I can't. If you're talking, I can't hear you. If you are prepping for 250, because you're going to take 250 with me, we use EF in 250. So all of this, scaffold DB context. There's the context and the models. We do both code first and database first in 250, but Entity Framework's kind of it's the dominant ORM in C#, with Dapper being number 2, but Dapper's very good. All right, that's all I've got, unless anyone wants to talk about anything else.
I want to say that thank you for joining. If anything, if I have any questions about DB, I would rather go to you than learn it myself. So thank you.
No problem. Happy to do it.
All right. So if no one here has any more questions, thank you again, Josh, for that amazing breakdown. I will have this posted online on the Canvas shell, so that way everyone can see it. And keep in mind, this is going to, if you want to get started early, if you are going to be in 250, so just reviewing these, get in practice, so that way you go in strong instead of having to start fresh. Take advantage and do not lose those coding skills during the summer, because yes, we can attest you will lose them. Any other questions before we stop recording on anything else besides database? All right then. Well, again, thank you for everything. Thank you, Josh. You all have a great day.